Simon Saunders, and I'm an honorary professor at the Smart Internet Lab here at the University of Bristol, but I've been working really closely with a lot of our other academic and non-academic colleagues on the JOINER infrastructure that you've heard a little bit about today. JOINER's being deployed, and you can see bits of it out in the square today. But there's a particular theme of what we wanted to do with JOINER, which is around radio spectrum, which is, of course, the layer zero, the very essence of any advanced wireless connectivity or any wireless connectivity period. And spectrum, if we want to support growth in whether it's revenues or services or just activity, spectrum, using spectrum well, is absolutely crucial to that. There are all sorts of terrible analogies for spectrum around property, that once you run out of property and they're not making it anymore, then you're in trouble. Spectrum's not like property. Spectrum's much more like oxygen. It is finite, but by reusing it, it can be unlimited. And actually, the government recognised this in their spectrum statement quite recently, saying this can create greater opportunities for growth by increased access to spectrum and ensuring that spectrum is not a limiting factor on the UK's economic and societal potential. In other words, that spectrum can be abundant, but it can only be abundant if we use and reuse it intensely and efficiently. To do that, we need to understand the very nature of spectrum much better. And actually, although there's been a lot of research in the UK on individual systems using spectrum efficiently, there actually isn't enough on the different systems that will share spectrum. So, to address that, we're building onto the JOINER capabilities that the spectrum eyes and ears, if you will, that will allow us to really inform innovation in that area. So there's a number of functions. First of all, we're monitoring for spectrum, and if you go and visit the JOINER Mobile, as I am told to call it, you will find the first spectrum monitor that we've literally got our spanners out this morning and made work, which will build really large-scale databases for our machine learning to understand the nature of real-world spectrum usage. Secondly, we've created a big stack of software-defined radios and associated software, so we can replay those spectrum recordings and create a synthetic environment, but based on absolute reality, that will allow us to test whether technologies can cope with that spectrum usage. Those software-defined radios will also allow us to emulate systems that will work in that spectrum and to optimize the algorithms. All these things together will create a spectrum digital twin for researchers to work on. And then last but not least, we're going to build our own spectrum assignment techniques, which we will actually use in research. We'll do the real dog food thing to grab the spectrum for experimentation and to show to regulators around the world how that's done. So this is together creating the JOINER National Spectrum Facility. So if you've got an interest in spectrum experimentation, come and talk to us. Thank you very much.